Hello guys, my name is Ian, and this week it's lesson number 8 in Paul McWhorter's Arduino with Python series. The homework this week was to get the humidity sensor of the DHT11 working. Let's have a look at the hardware. Hardware hasn't changed from last week. In fact, the software, the Arduino software in the hardware hasn't changed at all either. You can see that we still have the Nano, we still have the pot, we still have the DHT11, that's the blue module, and the DHT22, which is a more accurate version of the 11, that's the white module. So, not much to see in the Arduino front, but let's just confirm the code. So there we have it. It's pretty much the same code. I think the only thing I've changed is the commenting at the top for this lesson number. The rest of it's the same. It's still using the millis to do some form of multitasking within the loop, and updating 5 comma separated variables to the serial port for the Python to capture. So, as I say, not much to see here. If you want more information on this, please go back to the last lesson, the one from last week, part A in fact. Anyway, nothing to see with this. So let's have a look where all the action this week is. It was in the Python code. So here's the Python code. What's going on here then? Okay, so the main changes to the code this week is in and around my classes for my meters. The meter type one is the rectangular meter. I've made this this class a bit more, how shall we say, compatible with different requirements. So nothing's hard coded into it. So like 5 volts isn't hard coded into it anymore. Neither is the 1024 steps from the DAC. It's more general purpose. Could be used for any type of analog sensor. Other important thing to note in it is I now take in the value for the update. I take in the value that we're passing over, which is now the voltage, because I don't have the voltage and the number of steps. And to keep this function general, I'm not doing the DAC value, the ADC, the digital to analog to digital converter. I'm not converting that in this function. That's done in the code outside, which we'll see later. The other thing is the raw value, which is the actual ADC reading, the 0 to 1023, that's passed over separately if indeed you want to display it in the meter. If you don't, it's not displayed, it's turned off down here. Okay, and then the rest of it is because I'm making it more general. How I work out the angle of the meter is a little bit more general. Basically what I'm doing is I know the range of the needle is from 5 pi over 6 to pi over 6, and effectively what I'm doing is working out a proportion of that has been that the needle needs to move, and then moving at that proportion. So effectively I take in the value, I scale it correctly, and then I turn it into essentially a percentage of the range to adjust the value that the needle has to move through that 4 pi range, or 4 pi over 6 range. Right, main work this week has been on my meter number 2. Last week I didn't have a meter type number 2. This week I do, and as I wanted, because Keith had one, I've now got a round meter as well. We shall see that in all its glory in a moment. The main thing of key interest in this is my round meter has effectively a curved bar that lights up depending on how much the reading is. So if you imagine the reading is a percentage, if it's 50%, half the bar will light up. So how have I done that? Well, the easiest way to do it was to have 100 box segments, and then if the reading's 50%, I light up the first 50 of them. Simple as that. However, in order to be manipulating objects in Visual Python, you need to give them all a name. Now obviously having 100 boxes and 100 names is somewhat unwieldy. I could do it that way. It wouldn't be terribly good looking or a lot of fun. In fact, the better way to do it is to use a Python list. So that's what I do. I create myself an empty list here, and then as I create each segment, I add it to the list. And that means then if I want to address a segment, I just have to use its number, which, considering I've got 100 segments, basically means I use the percentage number. Simple as. Other interesting thing with this is how we then turn the bars, the segments on and off to make the bar light up. And effectively what I do is I work through the percentage, if we're assuming it's a percentage passed over to this meter, I work, if it's 50.5% for example, I work through the first 50 segments in this loop and turn them on and make them blue. That's what I do. So, well, actually I make them blue in this, in my code. The color you can actually pass over and have any color you like. Either way, it gets turned on, full opacity, and made that color. Then for the one like the 0.5, I make the opacity of the segment be 0.5, and then for the opacity of like would be the 51st segment in my example of 50.5, I make that 0.5, and then the rest of them, the 52 onwards all the way up to 100, I make them white and make their opacity just be whatever their percentage is, and that's to give a graded white bar going up. So meter type 3 is still there, not much change in that. That's just the thermometer bar. One thing to point out, what I have put into it, and I've actually put into some of the other meters as well, is a little bit of defensive coding here. What this is basically doing is checking that the value passed over is in fact within the scale limits of the meter. I did have a fault in my own code where I had set a meter which the scale finished at 70 and I was passing it over 80. So effectively my thermometer blew its top and went out the top, and that's not on for me. So basically what I've done is I've looked at the value being passed over, checked whether it's within the bounds of the scale, and if not, I clip it. So if it's too low, it's made to be the minimum that's acceptable. If it's too high, it's made to be the maximum that's acceptable. If it's in the middle, it is what it is. So that's that bit there. And then the rest of it's the same. So these are my meters. I'm drawing 5 meters because I've got the voltage meter, thermometer, humidity meter for the DHT11, and then a thermometer and a humidity meter for the DHT22. Stamp on my logo. I put a nice little pyramid because I was playing with pyramids. They look like a lot of fun. And then put it in the same panel. Same code as last week. I read in the serial if it's available, otherwise I'll flash an error unless I'm in test mode to begin with, which is my pseudo data function, which I exercise the meters with when the Arduino isn't even attached. Set up some initialization for these variables. Depending on which way you go through the infinite loop, it could be that you can traverse it without those being defined either from the pseudo function or from the Arduino, and that causes problems later on if you try to reference a variable that isn't defined. So this defines it to cover that problem. Now the pseudo function, well, not the pseudo function, the update function for the meters, to keep it more in line with how it works in the real world, I've simply changed that so the voltage meter is updated in time as we receive it from the Arduino, but I only update the humidity and temperature on every 10th run through the loop. That's what this bit with the modulus is doing. There's a counter, and every time it counts over to the 10, the modulus will be 0 and it will update those meters. That seemed to be a better way to do it, considering that I'm not expecting temperature and humidity to change as frequently as voltage might. Anyway, that's the code. Quite a lot going on, 360 lines of it. Everything will be up on GitHub as usual, and there will be links at the bottom of this video in the description. So let's have a look at what my meter looks like. And here we have the demo. So there we have it. Round meter, in my bar these 100 segments. They're all butted up close to each other and slightly turned in on the angle, but like what we do for the curved scale over here. So it's lit up as per the percentage that's being sent across, and there's a scale on the side of it, you can read it off, and then there's the label being given me the actual passed over. I can show you that it is live. I can change the voltage needle, and there we go. The temperature and humidity obviously doesn't change so much. It's quite stable in my room here at the minute, so I'm not expecting it to have any sharp changes unless the door opens or something like that. Anyway, that's my code. Hope you enjoy it. Any questions, pop them down below and I'll be pleased to answer them. Have a great day.